We're now going to develop the main menu design from the last video. We'll implement the 3 objects in GameMaker and test each of them in turn. If everything works out, we'll do a side-by-side comparison between our version and the original game. Let's load up GameMaker and start by pulling in the sprite assets. Create a new group to hold the menu sprites. Now we'll bring in the main menu sprite sheet in the Save Game slot sprite. We'll use the Select Color tool to replace the colors. We want to replace them with 0 alpha so that the backlight is visible through the sprite. Before we leave this screen, let's take a look at the Y coordinates of the sprites within the sheet so we can use them later. The main graphic begins at a Y of 50, the first pop-up begins at 250, and the second begins at 282, making these banners 32 pixels tall. Let's move on to the design document. We're going to build this network, which consists of these objects and these interactions. In GameMaker, we'll make a new group to hold our main menu objects. Now let's create the main menu object. We'll start with the create event by registering the keyboard. Now we'll define the states with an enum type, one for each possible menu option. Now the default behavior of the enum type in GameMaker is to count up by 1. We'll rely on this fact during the processing step. We'll need to initialize some variables starting with some state and selection holders. This select option variable will hold the state immediately after we make a selection. Now the usual fading variables. Now at the bottom, I want to hard code the top Y position of each of the menu options. Let's go find those in the file. Remember, we have to use the top of the sprite as the basis. Since the top is at a Y of 50, we'll subtract 50 from what we see. If we needed to implement screen scaling, these hard-coded values would need variables to provide a layer abstraction. Let's move to the room start event, which we'll need to use in order to guarantee that all object references are valid. We need the current game object. Now we'll set the menu selection option availability. The initial state we could have defined in the create event, but since I'm going to also put a special case after this, I want to keep everything together. Now, in a new game, the save and next mission buttons are unavailable. But if we're already in a game, they should be available. In fact, let's make the next mission button and the starting button available if we're in an active game. Destroy unregisters the keyboard. Now we'll look at the step event. We'll start by processing input. We'll pop the next command off the stack. Now we should be careful not to execute commands if the object isn't active. We don't have any easy inline check for that, so I'm going to make a function that returns true or false, and I'll call it isMainActive. Let's take care of that now. We'll create a new script group to hold main menu scripts. Now create the new script. We'll default to true, but then I want to check the cases that would make it false. Now the obvious one is if the object even exists. Then we'll check to make sure that none of the child objects exist. And back in the handler, we'll match the commands that we're interested in. The main only scrolls up, down, and reads the enter button. So if the user presses up, we'll advance the selection state. We'll zero out the selection alpha in order to create the fading effect. If the user has gone above the first entry, we'll wrap the state to the bottom. Also, if the user lands on an inactive state, we'll advance that as well. Now, this simple check won't behave properly if there's two inactive states sequentially, but that isn't the case in this situation. Now, ideally, this would recurse until a valid state happens. Now, let's copy this to the down button. This line's already correct, which means I made a mistake up here. Up should subtract from the state. Now we need to reverse the wrap condition. Finally, the enter button. We'll grab the state just in case there's some kind of inconsistency later. Then we'll switch on that state to decide where we need to go. Start new game should always go to mission 1, but if we have a game active, we'll need one of those pop-ups to appear. I'll make a function for this so to keep it clean. I think the restart game option was 2. Now if we aren't in a game, we'll just fade out. We'll follow the fade out routine for all the states that we program. Some of these I'm not going to handle right now. Quitting also leads to a pop-up. Now let me create these 3 objects now just to resolve some of the namespace misses the IDE is reporting. Let's make this create pop-up script now. It's pretty simple. I'll just make the object and set its type variable to whatever we pass. I'll call it pop-up option for now. I'll have to remember that when we get to programming the object. Now let's deal with fading. We'll always fade in the menu selector bar. And the screen fader will draw the black box, except this time 0 alpha means we're faded in. Now if we're completely faded out, then we need to jump to the next activity. For now, we'll keep it to starting a new game, moving the next mission, and saving or loading. Starting a game means mission 1, and we'll go to the briefing room. Next mission means we'll advance the current mission and go to the briefing room. Saving and loading means we'll create the load save object and set the mode. I think we'll call that variable mode. We haven't created the object yet, so this is dangerous. I think I'll also make the main menu object invisible just to keep the draw function from executing every frame while it's inactive. Now I admit that having the game flow programmed in the fading event is odd, and if we refactor this, I recommend decoupling this. Now we draw. Let's set the usual suspects. We'll then loop through the backlights. We only need to draw the maroon one since the background defaults to black. Now we'll draw the active selection. And we did end up drawing the active selection backlight twice, once in maroon and now in red. Just another refactor to think about. Now we'll overlay the entire sprite. Keep in mind that we're drawing only part of the sprite sheet, which we determined started at a Y of 50, but uses the full width. Let's add some fading animations. Now we can't test until the main menu object gets created in the room, so let's make an init script for the room and add the main menu object. Then we'll add the init script to the room. Okay, now we're ready to check our work so far. We'll go through the intro by pushing escape. Well, the main menu is here and we can move through it. We can't pick anything because that would either crash or hang the game since we haven't made any other objects. There is an issue with fading though. It's not happening at all, so let's look at the fading routine. I stepped the alpha up by 5, but I really wanted 5%. The fading was happening in one step. That should take care of that. Looks good now. Let's move to the loading and saving object. Remember that this object just handles the user interface. The current game object already has the data loaded into memory when we start the program, so we just need to reference and update it as necessary. Our main menu object creates the load save object by passing a variable called mode. Let's go for the create event. As usual, we'll bind the keyboard. Now we'll unbind it on the destroy event. In the step event, we'll process the keyboard input. We can copy the main menu object almost verbatim since we'll be using the same buttons. The up and down operations are almost exactly the same, except we check wrapping based on slot number. And there is no check for validity or changing of selection alphas. Now when we push enter, we want to make separate actions for saving and loading. We know which we're doing by checking the mode variable. I'm having trouble remembering the variable names. Did I even declare them? Oh, I skipped right over the variable declarations. Let's go back and do that. So select state will be the same as the main menu. The mode we passed during creation. Now the fading alpha and states. Mode 1 is save, and we'll have to simply set the correct variables in the game data array. To make sure we're setting the right thing, let's check the object. We have a 2D array for the save game slot, and each has 2 variables for kills and mission number. Now we should save the file. Now this would be a good place for a separate file saving script, except that this should be the only location that it appears in the entire codebase. I'll add that to the refactor list. Close the file and fade out, and go back to the main menu. On load, we'll pull the current data from the array. We should make sure the main menu flags are appropriate for the game in progress. Now since this procedure looks just like the one in the room start event for the main menu, it should definitely be handled by an interface script and not by this code block. Our refactor list is getting large. Oh, I forgot the escape button. It's the only way to get out of this room. Now let's deal with fading. Now onto the draw event. We'll hit the default settings. I'll draw the header at the top that lists the titles, the save game, mission number, and kill count. Since I've already put the header at the top, I'm going to take a different approach and draw the slots from the bottom up. To make this easier, I'll reset the sprite origin to the bottom. Looks like that's 18. Now I'll loop through and draw the sprite slots by subtracting its size from the bottom of the room. Now I'll warn you that this would be confusing for another maintainer to follow. I'm just doing this to demonstrate sprite origin drawing and manipulation. So in this version of the world, the currently selected slot will be highlighted when the current state plus I is equal to 10. We'll draw the slot in white. Now if that sounds confusing, everyone else in the world will agree with you. Now if there's no save data, we'll just draw an empty game. If there is, we'll draw the game data. Now we'll follow the usual fading routine by drawing the black square over the screen. We can't actually load or save data because we can't play the game yet, but we can see if the screen worked as intended. The enter button isn't working at all. Did I have it handled properly? Seems like I did. Maybe the keyboard object isn't trapping the enter key. Nope, it's not. Let's add a trap for enter. Actually, we also want a trap for the return key as well. Certain systems may distinguish between the two. Looks good. And we can escape out. We have one more object, the pop-ups that warn the player. We'll bind the keyboard and set the references to the game data. We'll initialize the variables. The new ones here include the offsets of the banners that we noted at the beginning. Now the first pop-up started at a Y of 250 and the next was 32 pixels below that at 282. Destroy unregisters the keyboard. Under step we process commands. Now remember that pop-up option 1 was the quit button, so if the player says yes, we'll end the game. Option 2 was the start new game banner, so we'll skip to the briefing room. Now I know the keyboard isn't listening for these keys, so let's add them. We'll use the ORD function to return the right comparison value. The drawing is simple this time. We'll fade the screen to about half strength. Then we'll draw the banner. Now I actually want to check to make sure there's a positive value in the pop-up option since we're using it here as an array reference. That should do it for the programming. Let's test the pop-up. I don't see anything. Not even the dimming black box. The only thing I can think of that would cause this is if the entire main menu object is being drawn over the pop-up object. And we can fix that by putting it on an earlier layer. GameMaker supports arbitrary layers, which affects the drawing order of objects. Otherwise, the object creation order takes priority. Now it looks good. Let's do a complete side-by-side of our work so far compared with the original game. We can see that the word spacing glitch from last time is fixed. A slightly different alignment here. The original game has some configuration options to deal with. Everything looks the same here at the main menu. We can scroll. Let's check the pop-ups. Almost perfect. The save and load screen look very similar. And we can actually go to the briefing room where the music is playing. Next time we'll design the objects that we'll need to bring this room to life.